Hi all. Last class we discussed about a machine tool, and today I'm going to discuss about a single point cutting tool. So this is the second lecture, and you just go through the notation, that is Mtdm M1L2. That means Mtdm Module 1 Lecture 2. So first of all, I will just say what is a single point cutting tool. See, a single point cutting tool is having only one cutting edge, and that is called a single point cutting tool. I will give an example. For if you are using a knife in your kitchen that is used for cutting fruits, vegetables, or fish, meat, etc. So a single edge is only sharpened in a knife. It almost 99% of the knives has only one side or one edge where it can be used for the cutting purposes. Similarly, a single point cutting tool just has only one cutting edge, and this is the most important cutting tool in the industry, that it has the purpose of one job or one purpose per tool. Okay, now we will go through the next topic, that is tool nomenclature, that is naming the parts of a tool. See, in this figure you can see a three figures. Actually these three figures just go through the six different labels that I am just about to tell. See, first one is the shank. Shank is the body of the tool. See, here you can see the shank. This is the shank. Okay, that is the main body of the tool. Then you can see the flank. This is the flank. Okay, so first one shank and second one flank. So this is shank and this is flank. Okay, and third one is the face. See, face is where the tool facing the workpiece, so that is face. Here is the surface where the tool faces the workpiece, so that is the face. And the fourth one is the base. See, here is the base. So base is the bottom part of a tool. And then the cutting edge. Cutting edge, see, in this tool you can see two cutting edges, that is, one is here, that is end cutting edge, and one is here, the side cutting edge. So the junction of the two cutting edges is called as cutting edge. Okay, so the junction of end cutting edge and side cutting edge is called as cutting edge. So the next thing is the nose. See, nose is the junction where, see, here is it is the nose, and here is the nose, and actually it is called as nose radius. I will mention why it is called as nose radius after some time. So the junction where the flank and the cutting edge meet is called as nose. So now we will move to the definitions of the different parts of a cutting tool. See, it is in a rhythm: shank, flank, face, base, cutting edge, nose. So the definitions are all written here. Just go through each and every definitions. That is, shank is the body of tool, flank is the surface of tool facing the workpiece, face is the surface of tool where chip slides, base bottom surface of shank, and cutting edge is the junction of end cutting edge and side cutting edge. And last one, nose is the junction of the flank and cutting edge. So these are the main names given to the parts of a single point cutting tool. Now I will just move to the next topic, that is very important topic. At least I can assure you 3 or 4 marks from this topic. So first, the thing you have to know, the principal angles in a single point cutting tool. See, it is very difficult for me to teach how the angle comes without drawing. Well, just try to make you understand the each and every angles. See, first angle is the back rake angle. So back rake angle is the see, here you know that this is the face, and this face is having some slope to the ground. See, in this figure you can clearly see that this this face is making some angle to the ground. So I will just and this, along this line, and so you can see that. So that is the rake angle. So actually this rake angle is how it is named is, see here you can see the angle, and here you can see the alternate angle of this. So the alternate angles are the same angles. So that's how we can write it as the rake angle. So first of all, that is the back rake angle. Similarly, it is for the back, and then one is for side, and that is called side rake angle. Similarly, there is end relief angle here. See, here is the end relief angle, that is, this is the end relief angle. And similarly, if there is one end relief angle, there is also a side relief angle. See, here is the side relief angle. And next one, end cutting edge angle. See, this is the end cutting edge. You can point along this, and this is the two lines that you can protrude. So this is the end cutting edge angle, and if there is end cutting angle, there is one side cutting angle. So there is a side cutting angle. So you can see the 6 different angles, and the last one is the nose radius. See, all the angles are given in degrees, but only the nose is given in millimeters. So that is nose radius. I will just go through. See, it is very difficult to understand all the thing by just looking at it. Just try to draw and label the angles, and so that you can easily understand the nomenclature of angles. See, I'll just go through the different 7 different elements of angles. So first one, back rake angle. It is a slope given to the face of tool. Second one, side rake angle, side inclination of face. End relief angle between end flank surface and line perpendicular to base. Side relief angle between side flank surface and line perpendicular to shank. End cutting edge angle between end cutting edge and axis of tool. Side cutting edge angle between side cutting edge and axis of tool. Nose radius. See, nose radius is a radius of a curved surface that joins end cutting edge angle and a side cutting edge. See, end cutting edge is here and side cutting edge is here. See, these two forms a circular shape, and this is the nose radius. See, this is the nose radius. So this is the 7 different elements or principal angles in a single point cutting tool. Now we will move to the next topic, that is types of rake angle. See, it is very important while doing a machining job. The types of rake angles you have to know. The first one is positive rake angle, and I also mentioned what is the purpose of a positive rake angle. See here, positive rake angle is used for soft metal cutting. Soft metal cutting mainly include mild steel, or you can also use some cast iron. See, all the metals, almost all the metals can be just machined by a tool having positive rake angle. See, the positive rake angle, see here you can see an inclination like this. Okay, see, if the angle is like this, then you can call it as positive rake angle. It makes small chips. I have mentioned about chips in the previous class. The increase in back rake angle forms thin chips, so that heat produced between the chips and the tool is lesser, so that tool have higher life, and also the surface machined by it will be so smooth. The next one is negative rake angles, and it is for hard alloys. See, basically hard alloys and hard metals are machined by negative rake angle. See the difference, that see here it is almost a perpendicular point it is making. So a lot of strength can be given to the hard metal alloys by using this one. See, it is very difficult for this, or it is very strong edge, whereas in the first one, the positive rake angle, it is a soft edge. It can be easily broken from here. So that is the positive rake angle for soft metal cutting and negative rake angle for hard alloys. And the third one is zero rake angle. Zero rake angle, you see the face will be making almost a parallel with the base. So zero rake angle form tooling, it is used for form tooling. Form tooling is the broad end tooling. See, broad end tooling means, see, consider a potter is making pots. He uses his whole hand to shape the mud. Similarly, a tool having a longer cutting edge or thicker cutting edge is called as form tool, and it is mainly have zero rake angle. Okay, so this is just used to to cut off the blunt edges or blunt sharpness in surface of a metal piece. Okay, now I'm going to the next important topic, that is the tool signature. See, in tool signature, basically the tool dimensions designations are all given by a association called as American Standard Association. See, ASA, American Standard Association is see, for example, you have a bolt of 8 mm. You can use a spanner of 8 mm to unwind the bolt from the nut, or you can just remove it from a nut having 8 mm from a bolt by using a spanner of 8 inch. Either I go to Gujarat and buy one 8 mm spanner, and if I go to Tamil Nadu and buy one 8 mm spanner, both have the same purpose and same dimension. It will not change. So for providing a university tooling freedom, there is one standard association called ASA, and according to ASA, tool signature is the designating the it is a system of designating the principal angles of a single point cutting tool. I have just given an example. See, this is the tool signature. See, you can see back rake angle. See, there is a small spelling mistake in it is back, BACK. Here it's a there is a small spelling mistake. Okay, it's not a problem. Back rake angle, side rake angle, end relief angle, side relief angle, edge cutting end cutting edge angle, side cutting edge angle, nose radius. Okay, so when you go to a shop and you want to buy a tool, you just give the shopkeeper these figures. That means 8, 14, 6, 6, 6, 15, 1. This is the designation of your tool. So he knows the first one, this 8 is the back rake angle. So he has to provide a tool with a back rake angle 8 degrees. And second one, 14. You can see the 14. See, 14 is the side rake angle. So he also know that the side rake angle should be 14. Similarly, the 6 and there are 3 sixes in 1 by 1. See, first one, end relief angle is 6, side relief angle is 6, end cutting edge angle is 6, and side cutting edge angle is 15. So he know the tool that he has to provide to the customer is 8, 14, 6, 6, 6, 15, and the last one is in mm. So that is nose radius, that is a dimension in this, that is a distance. So we have to provide millimeter for the nose radius. See, here you can see it is in a order. Okay, see, the order you have to be in uniform throughout the world, so that there is no change in the tool dimension. So you have to study the by heart. So it's easy to by heart by using, see, back rake angle, side rake angle. See, first two angles you study by heart: back rake angle, side rake angle. Then you can use ERA, SRA, EC, SC, nose radius. First one back rake angle, second one side rake angle. Then you can see ERA, SRA, EC, SC, nose radius. EC, SC, nose radius. So first two angles you know, back rake angle and side rake angle. The third one is ERA. ERA means end relief angle, and fourth one is side relief angle. Fifth one is end cutting edge angle, and sixth one is side cutting edge angle, and the seventh one is nose radius. So by hearting these things will provide you the so better marks, that because if you have any change in order while writing your answers in university exams, you will not be provided with much marks. So the by heart this order, that is back rake angle, side rake angle, ERA, SRA, ECSC, nose radius. Okay, so this much I have to tell for the second lecture. It is, I know it's quite a lengthy lecture, so try to study all these things. Okay, thank you.